Hello, thank you for coming today. We are doing a presentation on dirt, so soil, the soil health, and the difference between dirt and soil today. Let's just go ahead and jump right in. All right, dirt. Dirt is obviously our foundation. It's the foundation for all living life, all plants, and obviously it can be shelter for animals as well, bugs, insects. It's water filtration, so source of nutrients and minerals for pretty much all living things. So it's very, very important. I read a book on it and it was talking about the difference between dirt and soil health. And it was talking about how you can kind of tell the difference. And this is obviously a language, nuance, but it was talking about um, how dirt is it can be kind of crumbly, kind of dusty, whereas soil is I mean, you can say it either way. You have your plants in the dirt, your plants in the soil, but soil has that connotation of being more green, friendly, more green friendly. It's got more cohesion amongst the molecules and more nutrients. So it's said to be healthier because got, it sticks together, it clumps together more, whereas dirt is said to be less healthy because it kind of crumbles and falls and is dusty and it doesn't stick together. So generally that is indicative of soil health or at least what the soil is comprised of. So, and then we'll look at more at the chemistry of it later on in the presentation. And I am not an expert. I will say that right now. I just have read a few books on this, and so I have a lot to learn myself yet. But this is a beginner's presentation, so I think that that'll be okay. Um, so looking at dirt or soil, it can be comprised of three different things. We've got silt, sand, and clay. And silt is kind of the thinner, dustier-esque type dirt substance. Sand has larger kind of more solid molecular structures. A book said that they are bigger, so which is why they don't bond to each other on a molecular level because like the different chunks because they already have that solid like crystalline, I guess, arguably. It depends, of course, what it is, but that crystalline, that structure is already set, and it's not as easy to have those different chemical reactions with the larger chunks of earth, and then clay. And clay can be stickier, more dense. So. Those are what comprise dirt. This is from Teaming with Microbes by Jeff Lowenfels and Wayne Lewis. And so there, you can have a number of different soil makeups in any different place. And you can actually get your soil tested, get a couple coils, and you can figure out exactly what you have available to you on the land. And a lot of it's already been mapped. There are maps available online that you can kind of see this area is known to have this kind of earth here. And so that is good to know for if you are, say, a farmer or if you are trying to build, it is relevant. So some plants like certain types of soil better. Some do very well in like a more sandy loam versus like a silty clay. They're different environments, they're different ecosystems. So you can kind of see we've got sand, silt, clay in the corners. And then you've got sandy clay, clay loam, salty clay, or sorry, silty clay. Not salty clay. Silty clay loam, silt loam, loam, sandy loam, loamy sand, silt. And it's got different percentages here as well. This was taken straight out of a book. Um, you can actually test your makeup, um, your soil makeup as well at home. If you have a water bottle, you can put your soil into your water bottle and then kind of mix it around so that way it all kind of separates. And then you let it sit over time, and you can kind of see the different layers form in the water bottle based on density. So you can see the lighter particles on the top of the water bottle, then you have the other particles, and they kind of end up like with like. So that's how you tell what your soil is comprised of. So that's one way, unless you do want to, of course, call in professionals. But this is just an easy way you can kind of see at home what your soil sample does have inside of it. They do have at-home kits that you can also purchase, and those are available online, really through any online retail like superstores. You can find them, Amazon has them, and otherwise you can also go to specialty gardening shops and web browsers will generally, if you just type in soil tests, they can hook you up with pretty much any websites that have them for sale. Um, and it's pretty great. So you can purchase your own kits, and they can be tested for specific nutrients. Or you can send soil samples in to labs, specialty labs. I have not done either. Like I said, I am still new at this. I've read a few books, but it is interesting to see just what your soil is made of, and it would be very interesting to see the difference between like a professional lab workup versus your at-home lab. Obviously, it's fun to do things hand-on, so if you want to be able to do it yourself, definitely try it. It sounds pretty cool. So, but those are available to the general population. Um, uh, you just have to reach out to those places and hook yourself up with those resources. And so the question is, what is happening within the soil? Um, Now, this is obviously a very broad question. What's happening within the soil? You can figure out what your soil is made out of, but what's going on in it, like as we're living? Obviously, we have um, uh, bugs and animals that live underground. We've got water filtering through to the water tables below. And we've got root systems, really, really large, expansive root systems all throughout. And so rocks, soil obviously isn't the bedrock. We've got the bedrock as well. So there's so much happening under there, under the ground that we stand on, and we probably don't know the half of it, So it's a great question to kind of think like that. Think what is happening. We have worms and other insects, and they actually are contributing to the dirt, to the soil. They use it as a shelter a lot of times, a place to find food. Some of them do eat, say, like bacteria, fungi, as well as other small insects. And um, so. So they are actually great for that ecosystem. It's their ecosystem. They will eat, and then they also leave their castings, and or they poop essentially. They leave their fecal matter behind, and it's all, which is also a nutrient dense material. So we've got, I mean, it's small, obviously they're bugs. But but they help replenish the soil, the nutrients in the soil just by living in it. And they also help create aeration within the soil. And that's another thing that goes along with soil health is the the networks of, and you kind of hear that root systems can help with aeration. They kind of break up. You need aeration for proper drainage of water, like rainwater, any flooding that might happen. You need that drainage in order for the water to get down to the water table without causing as little minimal damage as it can to the ecosystems that are there. Obviously, the soil makeup. If it's not been upturned, that environment has probably adjusted to the rain levels of that particular area. And so you will probably see that when you see this land say, oh, the drainage isn't good here because look at what's here now. And, so that is something worth looking into. But worms actually um, can tunnel, bugs can tunnel, and they can kind of leave that space in the soil so that the water can drain through, and it also allows different gases potentially to get into those areas. Um, and so they are actually versatile elements of the ecosystem. But there are also chemical changes on the microbial level in the earth. And I kind of mentioned that too, that there are microbes, that the bugs will consume as like a food source. But it's not just the bugs, it is the soil itself having these different chemical reactions and these different bonds with different things. And they're not static. They don't necessarily stay the same. They're a part of the ecosystem and they kind of become part of that ecosystem. And so the soil gets the nutrients, and then the nutrients are transmitted into, to the bugs, to the plants, and then it needs to be replenished. And then you'll hear about, different fertilizers or different enhancements, ways that you can feed that soil health to ensure that it's there sustainably, longitudinally. So, like leaving the mulch, leaving your leaves out, and leaving just plant life to decay in that space, like in the agriculture with crops, having alternative crops or having a space buffer, a buffer plant zone that has other crops that will die and kind of replenish the soil there with their passing, and those can serve as homes for beneficial insects too. And again, the bugs do help the soil health with their castings. So, but that's just the starter. The starter package education wise for the chemistry of soil, looking at the bugs and looking at just basic things like, adding mulches. That's not the actual chemistry. And so I did read a book on this chemistry. I have not seen it. I don't have electron microscopes. I do not have tools available to me to be able to see gases, unfortunately. Um, but so this is what I have found in a book. It was talking about the different types of nutrients that plants can uptake. What do plants eat? And so it's talking about how it takes its nitrogen. And the book said that it can only take two forms of nitrogen, and it's nitrogen that is interacting with, has a chemical bond to hydrogen, and nitrogen that has a chemical bond with oxygen. And so we've got ammonium and we've got nitrates. And you can see the chemistry here, the actual chemical reaction. So nitrogen hydroxide, I'm guessing, um, and nitrous oxide. I'm guessing, of course, I apologize. I should have written it out. Nitrates. Here you can see the ammonium has a positive charge and nitrates have negative charges. And in chemistry, that just means like it's attracting or it's pushing away specific like electrons. Um, so this is what plants can eat. Ammonium is positive, nitrates are negative. And then it's in the book it said that vegetables, annuals, and grasses prefer nitrates, like bacterias, while trees, shrubs, and perennials enjoy ammonium or fungus. Um, and so so that means that the bacteria in the like the nitrates have that negative charge. So they have different chemical reactions, while the trees, shrubs, and perennials, looks like I'm missing a couple of commas there, I do apologize, um, have the ammonium, the more fungus. I think later in the presentation too, it talks about how fungus generally is established in is established in more established soils. And we can talk about that too. But this is just kind of like a hint of the what types of plants are thrive with this type of soil versus that type of soil. So, and that comes down to the chemistry of it. So it says clay and humus have a negative charge and are anions. So that means that they are looking for their cations, the positive charge, the opposite. So, because opposites attract. So, then, many nutrients do have positive charges and bond with the soils. So, the calcium, potassium, sodium, magnesium, iron, ammonium, and hydrogen all have positive charges. And so they are going to bond with the clay and the humus. And so um, it is literally a chemical reaction that takes place where these nutrients bond with the soil itself. And obviously you can think, well, the soil comes from, may come from like, rocks and minerals and things like that. A lot of it though is decayed materials. You do have those nutrients from like rocks and minerals, but um, a lot of it over time, obviously, it comes from the continued dropping of leaves, grass, other natural debris. That's also where the oils, that our fossil fuels do come from just over a much, much longer period of time. But that is where the soil comes from. And if you do happen to have the opportunity to, um, to see something decay, um, it does get darker over time. Um, and now this is actually I guess this is an interesting point because water can potentially dye things and make things lighter, whereas being, exposure to air can, like if you're looking at fall leaves, they start out kind of bright and then they sit through the winter and then they are much darker. And then like animals, they their matter will kind of turn black over time. as they decay. And so um, soil tends to be a black brown material. And that can be, of course, compost. Where does compost come from? You have your brown materials and your green materials, your fresh, freshly cut, fruits, veggie, um, rinds and things like that mixed with the browns of like the papers and the dead leaves and the things, and then you mix them together and you let the have add a little moisture, add a little water, and then you stir it because you get the chemical reactions and it starts getting hot. And so kind of the same sort of process does happen over time. And that's kind of where the soils do come from. It's composty science. So um, but this is the chemical reactions on the screen. Getting back to the presentation, sorry, I tangented a little bit with the compost, but having the positive charges and the bonds with the soil. And the cation fusion and uptake. I was reading about this to kind of understand it further because um, the nutrients do have the positive charges, and so they will connect with the soil, but it also it is also taken up by the plants too, and that is a process. Oh, I'm sorry, I'm missing. I feel like I'm missing a slide. Just maybe a couple. Gosh, I wonder what happened. Um, but oh, I think perhaps that just got put into a general presentation. Okay. But so the plants do take up the nutrients from the soils. And that is also a chemical exchange because they the plants give off exudates from their root systems, while they also absorb the nutrients that they need through the roots. And sometimes you do have like the microbiota there, the fungi at the root systems, like and I apologize, I'm going to say this wrong, mycorrhizae fungi. Sorry, it's a fungi. Um, that helps um, these help extend the length of the root systems. They create hyphae, so it just makes which are like this more stringy bits through from the fungi, and so it just it'll pull in nutrients to the fungi, and then the fungi eats the exudates, and then the fungi gives the root structures the nutrients that the roots need. So that's how they coexist by working together a lot of times to ensure that life progresses. And we have that same kind of relationship with coral in the ocean. So the coral reefs. So that it's pretty unique. Um, but and I do apologize. I the slides must have gotten put in a different presentation, like I said. But it's very, very interesting to think about all these different chemical reactions that you don't know of. And just that it's all so small and it's all happening all of the time in order to sustain life. So, are there any questions? Okay, I'm going to exit out of the presentation. I do have a couple of videos actually of um, just different types of soil, just a couple that were studied. Let me pull this up. And this is just a kind of a cheesy little video. I think it was made for kids. What's under the microscope today? But this is anthill dirt. So this is coming from an anthill. Ants excavated it out. So well, we can take a watch and see what it looks like. You can see already it's kind of crumbly and dry. Looks like there is some sand in it. And here it is under the microscope. So you can kind of see it does look like there are some larger particulates there, like definitely a sandier. And it must not have rained recently, or if it did, it perhaps dried. Um, but th that is what anthill dirt kind of looks like under the microscope. And this is what water saturated potting soil looks like under the microscope. Now, potting soil is when you purchase it, it is specifically for potted plants. So, if you've ever purchased it, it generally has a rich black color and it has chunks of like trees and different things like that. Sometimes you will have the chemical supplements of those little round bollies, potentially with nitrogen and phosphorus, depending on um, what the ratios are, because you can purchase those things with specific ratios of this much phosphorus, this much nitrogen, depending on if you're using it to kind of as like a corrective measure to kind of boost the health of a specific soil, or if you're looking for specific plants, because again, some plants do prefer more bacteria-esque soils versus fungi soils. So it can vary what you end up purchasing with soils and soil additives. But this is a basic potting soil, so it is going to be in theory, healthier than just what you might normally find. That anthill looked like it was in a yard, so it was just what you might find just in any yard, I guess. What's under the microscope today? All right, and it did say it was water saturated, so we take a look. It already does look, yep, blacker. You can see the wood pieces. And you can already see it's got different dimensions like decaying materials. You can see where the water actually has another kind of chemical bond going with itself, um, as well as with the soil too, um, because of the nature and the density of water. It does clump to itself, which is why you have like when you look, oops, apologies, we got commercials going here. Um, the meniscus, when you're looking at water in like a graduate or a graduated cylinder. When I was in school, we called it graduated cylinders. We called them graduated cylinders, and then I found out they shortened it. So the cool kids now call them graduates. Um, but let's go back. But because of the nature of the bonds of water, and that's another thing about water and the chemical reactions in soil and feeding the plants in the soil as well, because obviously you want that drainage, but you want the right amount of drainage, because if that water goes through that area too fast, then the plants aren't going to get the nutrients that they need. And if it goes too slow, you're going to end up with molds or, mildewy, perhaps unhealthy plants, unless they thrive in that environment. Um, water has that capillary action too, where it can kind of move um, up things. It can kind of spread more easily than other elements, other chemicals, I guess, chemical compounds. And um, so it does fuse to itself very well, and it likes to stick. And so that you can see very much on this in this video. I'm going to play it one more time just because I do think it's kind of interesting. I had another water saturated potted plant, and I finally said, I'm going to get some of this excess water out. The plant is not taking it up, and the plant wasn't dying, but it also wasn't growing to potentially its full potential. So, um, so I did end up having to literally take the soil. I dumped the water out, but it all had bonded to clumps of soil. So it was not, and of course it formed these big clumps because it had been bonded for so long. Um, so I literally had to, like, dumping it wasn't getting nearly enough water out. I had to take it between my hands, my fingers, and it literally squeeze this water out because it was bonded to itself and it was bonded to that soil and it did not want to let go. So, um, let's watch this one more time. Yep, you can already see there might be some rocks in there as well. But you can see the different chunks of the decayed matter in this. It just looks completely different from the anthill dirt. And there's the water right on it. It's pretty cool. And then if you know your rocks, your minerals, looking at the sand can kind of be interesting as well. Is like, oh, is that like a calcite? Is that, you know, what are those particles? Is it sodium? Is it, um, uh, let's look at this one more time as well. Oh, hold on. So very different. And I feel like this type of soil obviously is what you get after leaving it, with, potentially a fertilizer application on the top of your grass, but it's not a lot of um, the leaves and this in this area, probably in that yard. It didn't look like there was a lot that they were working with there. Let's see if it did have any. All right, you do see some of the matting of dead grass around it, so that could be a source moving forward, but nothing stirs it in ever. So any nutrients in theory would have to either be pulled through via water or via bugs that would take it up. So, and then deposit it through casting. So, uh, very interesting. Very, very interesting. All right. And nobody had any questions. So I guess we will leave it there. Thank you very much. Have a great day, and I will talk to you later. We'll see you for the next presentation.